Sound is everywhere. We hear it all the time. But what exactly is sound? Sound is a type of energy that travels as waves. These waves are created when something vibrates. Think about a drum. When you hit a drum, the drum head vibrates. This vibration causes the air around it to vibrate too. Those vibrations travel through the air and eventually reach our ears, where they're interpreted as sound. Pretty neat, right? But sound waves aren't visible like waves in the ocean. They're actually areas of high and low pressure that travel through the air. When these pressure changes reach our ears, they cause our eardrums to vibrate. Our brains then interpret those vibrations as the sounds we hear. Now, let's talk about pitch. Pitch is basically how high or low a sound seems to us. A high-pitched sound, like a whistle, sounds squeaky. A low-pitched sound, like a bass drum, sounds deep and rumbling. But what makes a sound high or low? That's where frequency comes in. Frequency is the number of vibrations per second. It's measured in hertz, or Hz. A high-frequency sound has many vibrations per second, while a low-frequency sound has fewer. Think about it like this. Imagine a hummingbird flapping its wings really fast. That rapid flapping would be like a high-frequency sound. Now imagine an elephant slowly waving its ears. That slower movement would be like a low-frequency sound. Musical instruments are amazing examples of how pitch and frequency work. Let's start with wind instruments like flutes and trumpets. When you blow into a flute, you create a stream of air that vibrates inside the instrument. The length of the air column determines the frequency of the sound. Shortening the air column by covering holes makes a higher pitch, while lengthening it creates a lower pitch. Next up, membrane instruments like drums. These instruments produce sound when their membrane vibrates. The size and tension of the membrane affect the pitch. A larger, looser membrane vibrates more slowly, producing a lower pitch. A smaller, tighter membrane vibrates faster, producing a higher pitch. Finally, we have string instruments like guitars and violins. These instruments create sound when their strings vibrate. The thickness, length, and tension of the string all play a role in determining the pitch. Thicker, longer, or looser strings vibrate more slowly, making a lower pitch. Thinner, shorter, or tighter strings vibrate faster, resulting in a higher pitch. Section 4. The monotony of monotone. Have you ever heard someone speak in a monotone voice? It can be pretty boring to listen to, right? That's because their voice is staying at roughly the same pitch the whole time. There's no variation in frequency to make the sound more interesting. Think about music. If every note had the exact same pitch, it wouldn't be very exciting. It's the changes in pitch and frequency that make music interesting and engaging. Section 5. Loudness. The power of amplitude. Now that we understand pitch and frequency, let's talk about loudness. Loudness is simply how loud or soft a sound seems to us. But what determines how loud something is? That's where amplitude comes in. Amplitude is the size of a sound wave. It's a measure of how much energy the sound wave carries. A sound wave with a large amplitude has a lot of energy and sounds loud. A sound wave with a small amplitude has less energy and sounds quiet. Imagine a rock being thrown into a pond. A large rock will create a bigger splash and bigger waves, or high amplitude. A small pebble will create a smaller splash and smaller waves, or low amplitude. The same principle applies to sound waves. Section 6. Measuring loudness decibels. We measure loudness in units called decibels, or dB. The decibel scale is a bit different from other scales you might be familiar with. It's a logarithmic scale, which means that each increase of 10 dB represents a tenfold increase in sound intensity. For example, a sound that's 20 dB louder than another sound is actually 100 times more intense. It's important to protect our ears from loud sounds, because prolonged exposure to high decibel levels can damage our hearing. So the next time you're listening to music, think about the science behind the sound and how you can protect your hearing.